Hey everyone, and welcome. Have you ever just stopped and wondered what everything around you is actually made of? I mean, really made of. From the device you're watching this on to the very air you're breathing right now. Well, today we're going to kick off a journey into the amazing world of chemistry to answer that exact question. We're going to explore what science is, what chemistry is, and how it connects to, well, literally everything. All right, so let's just dive right in with that big question. Go ahead, take a look around you. The chair you're sitting on, the air in the room, your phone. What's the one thing they all have in common? The answer is actually pretty simple, but it's also incredibly profound. They are all made of matter. So what is matter? The scientific definition is beautifully simple. Matter is just anything that has mass and takes up space. This pen right here, it has mass and it's definitely occupying space. Your screen does too. But here's the really cool part. Even the air, which you can't even see, is matter. It has mass and it's taking up all the space in the room around you. Yep, matter is basically the fundamental building block of our entire universe. But, that makes you wonder, right? How do we actually know all this? How can we be so sure about what matter is? Well, that's where science comes in. Before we get into the nitty-gritty of chemistry, it's really important to understand the powerful process we use to learn about the world. It's so easy to think of science as just a giant book of facts, but it's really not that at all. It's a process. It's a way of thinking. And it all starts with something super simple. Observation. Just noticing the world with your senses. You might see a plant bending towards the sunlight. But the real magic happens in the next step, experimentation. We actually design a test to figure out why it's doing that. That powerful combo of observing and then testing, that's the engine behind all of science. Okay, so now that we've got a handle on the process of science, we can zoom in on our main event, chemistry. You can think of it like this. If science is the entire toolkit for understanding the universe, then chemistry is the specialized tool we grab when we want to understand one specific thing, and that thing is matter. So what does a chemist actually look at when they're studying matter? Well, it really boils down to three main questions. First, what are its properties? Is it a solid, a liquid? What color is it? Second, what is its composition? In other words, what are its ingredients? We all know water is H2O, that's its composition, hydrogen and oxygen. And third, what's its structure? How are those bits of hydrogen and oxygen actually arranged and connected to each other? Now, you might be thinking, properties, composition, structure. Okay, that sounds like stuff for a science lab. But here is the single most important thing I want you to get from this. Chemistry isn't just stuck in beakers and test tubes. It is happening all around you, all the time, right now. Let's just start with the clothes you're wearing. The fabric that makes them feel a certain way, the dyes that give them their color, those are all the result of very carefully designed chemical processes, all to make them look good and last a long time. Or how about the soap or shampoo you use this morning? That is a fantastic example of chemistry in action. You see, soap molecules are cleverly designed with one end that loves to grab onto dirt and oil and another end that loves water. So when you rinse, it just washes the whole mess away. Pretty neat, right? And of course, there's the food you eat. The next time you cook an egg, you're literally watching a chemical reaction happen right in front of you. That heat causes the proteins inside the egg to completely change their structure, turning that clear, gooey stuff into a solid white. That's pure chemistry. So what's the big takeaway from all this? It's that from the moment you wake up in the morning to the moment you go to sleep at night, you are completely surrounded by and interacting with the world of chemistry. It's not just some subject you study, it's the science of your life itself. Now, because chemistry is such a huge and important field, it would be impossible to study everything all at once. So, to make this massive topic a little easier to tackle, scientists have broken it down into several main branches. Let's take a look at some of the big ones. First up, we have physical chemistry. This branch is all about the physical identity of a substance and the rules that govern it. It asks the big why questions, like why is ice a solid but water is a liquid? It digs into the states of matter, solid, liquid, and gas, and the energy that makes them change from one to another. Next, there's inorganic chemistry. Now, this is a huge area that studies, well, basically all the chemical compounds that aren't based on carbon. We're talking about metals, minerals, salts, all the stuff that makes up the Earth itself. This is super important for industries that make things like glass, ceramics, and even for pulling metals out of the ground. And on the flip side of that, we have organic chemistry. This branch focuses almost entirely on the chemistry of just one element, Carbon. Now, that might sound kind of narrow, but here's the aha moment. Carbon is the absolute superstar of the periodic table. It can form these strong, stable bonds that let it create the long chains and complex rings that are the literal foundation of all life as we know it. The proteins, the DNA that make you, you? Yep, all organic compounds. So this slide really lays it out perfectly. On one side, you've got inorganic chemistry, which covers this vast world of other elements, metals, minerals, the stuff of rocks and earth. And on the other, organic chemistry, which takes this deep dive into that one special element, carbon, which gives us everything from plastics and medicines to life itself. Moving on, we have environmental chemistry. This branch takes chemistry right out of the lab and into the world all around us. It studies all the chemical reactions happening in our air, our water, and our soil. This field is absolutely critical for understanding things like pollution and, more importantly, figuring out how to protect our planet. And finally, we've got analytical chemistry. I kind of like to call this the detective branch of chemistry. An analytical chemist's job is to figure out exactly what is in a sample and how much of it is there. Is this water safe to drink? What chemicals are in this new medicine? These are the kinds of mysteries they solve, which makes this field unbelievably important for things like food safety, medicine, and even forensics. So there you have it. That was a super quick tour of the huge and exciting world of chemistry. From the physical laws to the very basis of life, all these different branches are just different ways of looking at and understanding matter. We've laid the groundwork, but our journey is really just getting started. But before we go, I want to leave you with a fascinating question to chew on. We've talked about the 3 common states of matter, right? Solid, liquid, and gas. But here's a little puzzle for you. Could a single substance, like water, actually exist as a solid, a liquid, and a gas all at the very same time, in the same place? Think about that, and we'll uncover the surprising answer in our next explainer. Thanks for joining me today.